All right, let's talk about one of the biggest challenges in the cloud today. How do you really know what's going on inside those incredibly complex, distributed systems you're running on AWS? Sometimes it can feel like you're trying to find your way through a maze completely in the dark. But stick with me, and by the end of this, you're going to have the map and the flashlight.
So let's just start with a really honest question. What is actually hiding inside your system? We build these incredible, powerful applications, but when something breaks, really breaks, finding the why can feel impossible. It's like looking for a needle in a haystack, right? Well, that's exactly the problem we're going to tackle.
Now, before we get into all the cool tools and the how-to, we have to get the why right. And that starts with making a really crucial distinction, the difference between observability and what we might call old-school monitoring. They sound kind of similar, but trust me, they are fundamentally different ways of thinking about the health of your system.
This right here, this comparison, it perfectly captures that shift from just knowing what is happening to understanding why. Let me give you an analogy. Monitoring is what tells you there's a traffic jam. It sees your CPU is at 90% and it sends you an alert. It answered a question you predefined, but observability? Observability lets you ask why that traffic jam exists in the first place. It lets you explore and discover that, oh, a little downstream service suddenly got slow, causing this huge backup. See the difference? Monitoring answers the questions you already know to ask. Observability lets you ask entirely new questions you hadn't even thought of yet.
Okay, so how do we actually do this on AWS? Well, that brings us to our toolkit. And the first stop, the absolute foundation of any observability strategy on AWS has to be CloudWatch. I want you to think of this as your command center. So CloudWatch is really built on these four main pillars. You've got your metrics. These are the raw numbers, right? CPU usage, network in, network out. Then you have logs, which tell the detailed chronological story of what your application was actually doing. You've got alarms, which are your automated watchdogs, firing off when a metric crosses a line you set. And finally, dashboards, which bring everything together in one visual place. Seriously, it's like the air traffic control tower for your entire AWS environment. It gives you that high-level view you need to operate safely and spot trouble from a distance.
But what happens when you spot something weird from that control tower? You need to send a detective down to the ground to investigate, right? Well, if CloudWatch is the tower, our next tool, AWS X-Ray, is that detective. It's designed specifically to follow the trail of evidence through all your interconnected services.
An X-Ray's secret weapon is something called a trace map. It's basically like putting a GPS tracker on a single user request. You get to see its entire journey, from the second it hits your front door, through every single microservice it talks to, all the way until response goes back. And the crucial part? It shows you exactly how long it spent in every single step of that journey. And this is how engineers use it to hunt down those really tricky performance problems. You just pull up the trace map for a slow request, and boom, you can immediately see which service is taking forever. Imagine seeing that your payment API is suddenly adding 2 whole seconds to every single transaction. From there, you can drill down and find the exact function causing the delay. This completely changes the game from guesswork to a data-driven fix. It turns a mystery into a simple, solvable problem.
Okay, so AWS native tools are great, but let's be real. In the modern tech world, we're almost always using services and technologies from a bunch of different vendors. So how do we get all of those things to speak the same language? That is where OpenTelemetry comes in. Think of it as the universal translator for all your observability data.
And this quote really gets to the heart of why OpenTelemetry is so incredibly important. It's all about avoiding vendor lock-in. You know that feeling when you're so deeply tied into one company's ecosystem that you're just stuck, even if a better, cheaper tool comes along? Yeah, OpenTelemetry as an open source standard is designed to prevent exactly that.
So basically, OpenTelemetry gives you one standard, unified way to collect all your telemetry data, your traces, your metrics, your logs. It doesn't matter what programming language you're using or what platform you're on. This is huge because it future-proofs your entire setup. It gives you the freedom to send your data to any analysis tool you want, whether that's an AWS service or something else entirely, today or 5 years from now.
All right, let's zoom out for a second. We've talked about some amazing tools, but I want to be clear. Mastering observability isn't just about installing some software. It's really a cultural shift. It's an evolving practice, a journey that every organization has to go on. I want you to think of this as a kind of roadmap for that journey. Most teams, and let's be honest, they start at stage 1. They're totally reactive. An alarm goes off and it's all hands on deck to fix it.
The goal is to move up to being proactive, spotting trends before they cause an outage. And then you get to the really advanced stages, predictive and innovative, where you're not just fixing problems anymore, you're actually using data from your systems to drive smarter business decisions. So take a look. Where do you think your team is on this model right now?
So let's bring this all together. Let's make it super practical. How would you actually use these tools to solve a really common problem, like a performance bottleneck? Well, this workflow shows you exactly how. You'd start high-level in CloudWatch. Maybe you notice response times are creeping up. That's your signal to dive deep with an X-ray trace to pinpoint the exact slow service. Then you can jump over to the logs to look for specific error patterns. And finally, you confirm your fix by running some load tests to make sure it holds up under pressure. It's a systematic hunt, and it's all powered by data.
Because really, at the end of the day, that's what this is all about. It's about building systems that are more resilient, more reliable, and just perform better. When you move from simple monitoring to deep observability, you stop just fighting fires. You start building a system that's fireproof. So I'll leave you with this to think about. Where are you and where is your organization